Hello friends, welcome back to Edupedia Word Videos, your destination to free education. In this video, we'll be dealing again with two proof-based questions. So here goes some more examples. The first question says, prove that tangent square A minus tangent square B is this fraction. So let us start with left hand side. The left hand side is tangent square A minus tangent square B. Now since we need sine and cos term or their squares, just convert tangent into sine over cos. That is, use tangent of A is sine A over cos A. So we will have here, it is tangent A whole square minus tangent B whole square. So it is sine A over cos A whole square, which will be sine square A over cos square A. Similarly, this part will be sine square B over cos square B. Now we need in right hand side the denominator as cos square A and cos square B. So taking the LCM, we will have cos square A into cos square B, and the sine square A will be multiplied by cos square B minus cos square A into sine square B. Now we need only sine square of A and B. We doesn't need cos square of B or A in the numerator. So using the identity sine square A plus cos square A is 1, it will give us cos square A is 1 minus sine square A. So we have sine square A into 1 minus sine square A, and similarly for B it will be cos square B as 1 minus sine square B. Sorry, here it was B, and here it will be 1 minus sine square A into sine square B over the denominator. So we have, opening the brackets, sine square A minus sine square A sine square B minus sine square B, and minus and minus will be positive, of sine square A sine square B over the denominator. So this term will cancel by the negative of it, and hence we are left with sine square A minus sine square B, and the denominator, which is cos square A into cos square B, which is the RHS, sine square A minus sine square B over cos square A cos square B. So by starting from the left hand side, we have achieved the right hand side, and hence the given question has been proved. Let us have the second question. Now we have to prove that A square minus B square is 4 under root AB, whereas we are given the values of A and B. Friends, one simple alternative is to calculate A square and B square as such, but A square will give us tangent square plus sine square plus 2 tangent into sine. So it will be a complicated situation because we don't have any identity involving tangent square and sine square, and moreover tangent into sine. So this alternative should be discarded. What more can we do? Friends, see, we are having two linear equations. So we can calculate the value of tangent and sine. No doubt we'll be having tangent and sine values, and no doubt we don't have any identity involving this term, but the reciprocals, that is cot and cosecant, they are related with a particular trigonometric identity, that is cosecant square theta minus cot square theta is 1. So we'll be using that particular identity over here. Let us see how. We are given with tangent of theta plus sine theta equals A, and tangent theta minus sine theta equals B. So firstly, just add 1 and 2. 1 plus 2 will give us the sine theta will get cancelled with the minus of sine theta, and we'll be having 2 tangent theta equals A plus B. That is, tangent theta is A plus B divided by 2. Whereas if we subtract 2 from 1, we will have tangent theta plus sine theta equals A, and minus of tangent theta minus sine theta equals B. That is, A minus B is sine minus of minus is plus, so sine plus sine, that is 2 sine theta, or sine theta is A minus B by 2. Now, as we have already told that we will reciprocate the tangent and sine to use the identity, so we will be doing over here. What is cot theta? It is reciprocal of tangent theta, so it will be 2 over A plus B. Now what is cosecant theta? It is reciprocal of sine theta, so it will be 2 over A minus B from here. So now, using the identity, that is cosecant square theta minus cot square theta equals 1, we have 2 over A minus B whole square minus 2 over A plus B whole square equals 1. That is 2 square, which is 4 over A minus B whole square minus 2 square, which is again 4 over A plus B whole square is 1. 4 can be taken common, so we have 1 over A minus B whole square minus equals 1. This 4 bringing to the other side, it will be 1 by 4, and taking the LCM, we have A minus B whole square into A plus B whole square, and in the first part the numerator will become A plus B whole square, and here it will be A minus B whole square. Now friends, A plus B whole square is A square plus B square plus 2AB, whereas A minus B whole square is A square plus B square minus 2AB. So if we subtract this thing from this thing, A square minus A square will be 0, B square minus B square again 0, whereas 2AB and minus of 2AB, so it will be 2AB plus 2AB, which is 4AB. So the numerator becomes this thing, that is, on subtracting we have 4AB over a minus b into a plus b whole square, because square on the both sides, equals 1 by 4. So on cross multiplying, we'll have 4ab into 4 equals a minus b into a plus b is a square minus b square and its whole square. This term as this and whole square over here. So as a whole we have 16ab equals a square minus b square whole square. Now we have to find a square minus b square, but here we have a square minus b square whole square. So take square root on both sides, which will give us under root of 16ab is under root of a square minus b square whole square. So as a whole we have under root 16 into under root ab is this under root will cancel this 2, so a square minus b square. So we have 4 under root ab as a square minus b square, or simply a square minus b square is 4 under root ab if we shift the sides. So we have achieved the required result, the to-prove part, and hence the given question has been proved. Let us have one more question. The question says, if secant theta, the value of secant theta is this, find the value of secant theta plus tangent theta. Friends, we have to find the value of secant theta plus tangent theta, but we are given only secant theta. So how can we find the value of tangent theta? My dear friends, we have an identity which says secant square theta minus tangent square theta equals 1. We can find out the value of tangent square theta from this particular identity. So secant square theta minus 1 is tangent square theta, bringing this tangent to right hand side and 1 to left hand side. So we need to find out secant square theta minus 1 so that we can calculate tangent square theta. So secant square theta minus 1 is x plus 1 by 4x whole square minus 1, which is x whole square plus 1 by 4x whole square plus 2 into x into 1 by 4x minus 1. Now this part, if we can simplify this part, 2 into x into 1 by 4x is x get cancelled, 2 cancels 4 and leaves 2, so 1 by 2. So in other words, in this case 2ab is 1 by 2. So 1 by 2 minus 1 will be LCM as 2 and 1 minus 2, that is minus 1 by 2. Friends, we have preserved a square and b square, but we have now acquired 2ab with the negative sign, that is minus 1 by 2. It can be written as 1 by 2 into 4x, so it becomes minus 2 into x into 1 by 4x. So the point here is we now have a square plus b square minus of 2ab as a whole, 3 terms, that is x square plus 1 by 4x whole square minus 1 by 2. So it becomes a minus b whole square. that is x minus 1 by 4x whole square. So we have secant square theta minus 1 as x minus 1 by 4x whole square, and secant square theta minus 1 is tangent square theta. So we have tangent square theta as this. On taking square root of both the sides, it will give us tangent theta equals under root of x minus 1 by 4x whole square. That is tangent theta equals plus minus x minus 1 by 4x. This plus minus has been justified in previous videos why to use this plus minus 4x. Now we have to find out secant theta plus tangent theta. Friends, this plus minus can also be used in the previous this square root part, but here we was only needed 4ab, so we have discarded the negative part. Now in this question we need to find out secant theta plus tangent theta. Now secant theta is given as x plus 1 by 4x over here. So secant theta plus tangent theta will be x plus 1 by 4x plus minus x minus 1 by 4x. Now breaking the plus and minus part separately, we have x plus 1 by 4x plus x minus 1 by 4x and x plus 1 by 4x minus x minus 1 by 4x, either this term or this term. Here this 1 by 4x get cancelled because it is present in both positive and negative sign, so we have 2x. Whereas in the second part, when negative sign is bring and the brackets are opened, we will have minus of 4x and minus is plus of 1 by 4x. So this x cancels by minus of x and we have 2 into 1 by 4x, which is because 1 by 4x is present 2 times, so we can use 2 into 1 by 4x. So 2 cancels 4 and leaves 1 by 2. Hence the value of secant theta plus tangent theta is 2x or 1 by 2x. So it was the desired part, and hence we have achieved the desired result. So friends, that's all in 2 proof based questions on trigonometry. Thanks friends for watching Edupedia word videos.